Dun dun dun. If you want to learn about Newton's laws, then you have come to the right place. Now let's begin with the first law that Newton stated. Every object in a state of uniform motion tends to remain in that state of motion unless an external force is applied to it. This means that in order for an object to move, a force has to be applied to the object, or in order for an object to be stopped, a force must be exerted upon it. Let's take a look at an example. A ball on a table remains stationary until a net force is exerted upon it. Once the ball starts moving, it stops. Why is that, you ask? Well, that is due to the cause of the friction force of the table. If we now remove air pressure, gravity, and the table from the room, the ball remains stationary in the air. Until a net force is applied to the ball, it will remain stationary. Now let's apply some force to the ball. Once a force is applied, the ball will accelerate at the start, then move at a constant velocity forever. The ball will never stop moving until a force is applied opposite the direction of the ball that it is traveling to. What is the force applied to the object, you may ask now? We can actually solve this using Newton's second law. The relationship between an object's mass m and its acceleration a and the force applied F is F equals ma. Acceleration and force are vectors, therefore the direction of the net force vector is the same as the direction of the acceleration vector. We plug in the equation and we get F equals 10 times 15, which is 150 kilograms meters per second squared. We can also rewrite this as 150 newtons. This is because a newton is equal to 1 kilograms meters per second squared. Note here that the velocity of the ball is equal to the acceleration of the ball. This is because the force was applied only at the beginning, and since the object moves at a constant speed after the force has been applied, the magnitude of the acceleration and the velocity is the same. Another way of looking at this would be that the acceleration only lasts a second, therefore the velocity is 10 meters per second. Now let's go to the final law of Newton, which states that for every action there's an equal and opposite reaction. This law can be demonstrated when a dog sits on a table. When the dog sits on a table, it exerts a certain amount of force to the table. This is visually apparent on a regular basis, but the thought of the table pushing back at the dog with an equal force is a thought that's hard to visualize. Now, if the force exerted by the dog is greater than the force applied by the table, then the dog would simply, fall down. I hope this helped you for your test. Until your next test, bye.